Hello everyone, myself Ankur Tawar. I will be presenting my assignment, and here I am taking some uh, data and examples of some drugs. First one is the hydrochlorothiazide. It is the drug is used for treat the hypertension and swellings due to the fluid buildup. Here task one is that we need to make the crystal structure or the structural model of this drug with the help of Olex2 software, and then we will refine to a more real model. So first is that what's the molecular structure? We get that it has 7 carbon, 8 hydrogen, 3 nitrogen, 2 sulfur, and 4 oxygen, and 1 chlorine, which are indicated in the diagram with a different color coding. And this is the molecular formula of the drug. Next, this bonds and geometries. This represents the molecular connectivity and arrangement of the drug. Second is the crystallographic data. So this is showing a space group of P21, and it is showing a monoclinic system. Here are the unit cell parameters A, B, C, and alpha, beta, gamma. Here beta is not equal to 90 degrees, so this structure is a monoclinic here. And A, B, C are the lattice parameters of the unit cell, where Z is the number of atoms, and R is the residual factor here. So we got the residual factor of 3.76%, which means that it is very good model, and it resembles the more to the real model. So this residual factor is calculated by difference of the actual model and calculated model. So if this difference is less, small, so our structural model is more close to the real world model. So residual factor 3.76% means it is a better agreement between the observed and the calculated structure factor. Here in this Olex2 we use refine the structure to get more close to the real structure. Here thermal vibrations. We know that the atoms in molecules usually vibrate with some thermal energy, and they vibrate around an equilibrium position. So we have used the ellipsoid feature in the Olex2 software, which can add the thermal vibrations to it. So thermal vibrations are added, and the structural model can make more close to the real structure of the drug. So R factor also decreases. So these are the crystal packing diagrams of the R drug with the various different orientations. So this is hydrochlorothiazide in a lattice, and along various several lattice parameter directions. So this is the random direction, and when it is observed from the A direction, so this is observed like this, and if we observe along B, we get this type of lattice cell, unit cell, and along C we'll get to observe this type of cubic close packing of the drug in the unit cell. The task 3 is that we need to get the powder XRD diffraction pattern diagram. So this is actually first we make the powder of the R crystal so that we can get the powder XRD. Here on the x-axis this is the 2 theta diagram. 2 theta, it represents the diffraction angle which is measured in the experiment, and these various peaks are observed at various specific different angles, and these peaks are observed corresponding to different HKL planes as per the Bragg's law is defined. So for different planes, and when we apply the Bragg's law, we'll get the different peaks at different angles. And on y-axis there is an intensity which shows that the intensity of the diffracted X-ray means at these peaks there is the constructive interference of the two diffracted rays. So it these represents the electronic density and the atomic arrangement of the crystal. So this represents that the good match between the observed and the calculated peak confirms the phase identity and validate the structural model. So second data is the rule. This is the data 2, and this drug is rulizole plus malonic acid, and here we have solved the structure model using the XRD data of the various HKL planes and the intensity and the standard deviation of the peaks. So this is the structural model, and this is the molecular formula C11H9F3 and 2O5 and S. So this is our monoclinic system P21/C, where 21 is the screw axis, and as we know that beta is not equal to 90 degrees, so this is a monoclinic system, and these are the various cell parameters. And structural factor obtained in this model is 3.7%, which is a low value and better agreement between observed and calculated structure factor. And we have also incorporated the thermal vibrations of the various atoms. These are the crystal packing diagrams of along the various direction A, B, and C, and this is the powder XRD of the malonic acid plus the rulizole, and as this is the 2 theta and y-axis is the intensity, so various peaks are corresponding to different HKL planes, which are obtained using the as per the Bragg's law, and these peaks defines the where is the electron, so electron density and atomic arrangements can be calculated using that. The third data is the rulizole plus orthophosphoric acid. This is the rulizole, and this one is the orthophosphoric acid, and this is the structural model. So this is the molecular formula we obtained, and the crystallographic data shows that this is the monoclinic system P21/C, primitive screw axis perpendicular to the C axis, and these are the parameters. Here beta is also not equal to 90, so this is also a monoclinic system. Residual factor obtained here, it's 3.32%, which is a low value, so quite good model, and very close to the observed model. Here thermal vibrations are added using the ellipsoid feature. These are the crystal packing diagrams along various axes A, B and C, and this is also the powder XRD of the third drug, which is rulizole plus orthophosphoric acid, and these peaks defines the various electron density and atomic arrangements of the crystal. So thank you. Hello everyone, we will make a structural model using this Olex2 software. So first I will open the XRD pattern data, click on the open, and here I will show you that this ropa.htl, but it's uh, in this this is the various data. These are the HKL parameters, and this is the intensity corresponding to different HKL planes, and this is the standard deviation corresponding to that peak. So this XR data can be used to make a structure model. So first I will open this ropa.ins, which will also helpful. So it is I will click on the work, and so yes, so I will click on the work that it is using a shell access program to calculate the structure. So click on the solve button. So now you can see that this is some hexagon, some type of hexane structure. We can make these carbon atoms, as we can predict that there are 8 carbons, 8 hydrogen, 2 nitrogen, 5 oxygen, 3 fluorine, phosphorus and sulfur. So I can use the make the structure by prediction. So I will make these 6 atoms, 6 electron density as carbon. Click on the carbon. So it is made as carbon. Now what I have to do, that these highlighted yellow balls, these represents that these are very high electron density. So these are already highlighted. This is S1 and S2. As you know that there is one sulfur and one phosphorus. So one of them is phosphorus. So make it. Let's make this one as phosphorus. Now, so this structure. Uh, First, then we can do. Now you can see that this is making some connection. So this might be high density, so this I can denote as oxygen, and this is the phosphorus, so 5 oxygen, so 1 oxygen I have used here, and might be, so first, yeah, you can see that this is also making some pentane ring, so this might also be carbon. So I will select these balls and assign carbon to them. Now you can see that this has been formed, and these electron density might be nitrogen, so I will make this as nitrogen, and this as in this we are having the 3 fluorine atoms. So this is a seem to be a tetrahedral structure, so 1 carbon, and it's attached to the 3 fluorine atom and 1 oxygen atom. So I can assign this as carbon, and these 3 are the fluorine atoms. I can make them fluorine. So now you can see that now this carbon is having tetrahedral valency, 4 bonds, and this oxygen is also forming 2 bonds, so this is also fine. Now this phosphorus, it might make 5 bonds, so this might be covered with oxygen. So what we'll do that we assign them some oxygen to them. So I will click, one oxygen we have used there, so 4 are remaining, so I will assign these as oxygen. Now what you can see that this is making some PO4 type of structure, phosphate ion, and we are remaining here one nitrogen. There are two nitrogens, so I have used one here, and this might be a structure of rulizole. So this carbon 3 can be a nitrogen. We can use some hint, and here we will click on the refine button, so the structure will get refined. And as we can see that the structure is having 10.22% residual factor, so we can also increase the number of cycle to 8, and we'll click on again refine. As this, you can see that as the number of refinement cycle is increased, then the residual factor is dropped to 10.09%. Now this is not sufficient, so we need a more good residual parameter, so we need less than 5%. So what is remaining, that these valencies are not satisfied, so we'll add a hydrogen to them. So this software automatically adds the hydrogen as according to the hybridization and the type of atom it is. So now this R factor is reduced to 9.64%. It's more close to the real model. So now this is forming a hydrogen bond as denoted by the dotted red lines, and now we need more correct form. So what we'll do that this will click on this ellipsoid feature, which will add this thermal vibrations to it. So these atoms are vibrating about its equilibrium position. So by clicking on it, the electron density will make an ellipsoid. So upon clicking this, these atoms will become ellipsoid, and as you can see that R is dropped to 3.2%, 3.32%, which is a very close and which is better agreement between the structure model which we have calculated, and the observed model, which is the real world model. So as you can see that this is a fine structure model. So this is the rulizole plus orthophosphoric acid. Now we can generate a zip file by clicking on this acta and refine it. Now what we'll do, we open the Vesta software. So this Vesta software, I will click on open the new structure. Oh sorry, I will open the zip file. So this is the data 3 downloads. So this zip file is generated, and I will open it. So now you can see that this is the unit cell close packing. So this is the close packing diagram of the rulizole plus orthophosphoric acid, and we can see with the different orientations, A dash, B prime, C prime, and I can also make the powder diffraction. I click on the utility and add the powder diffraction pattern. First simply I click on the calculate button. Now you can see that this is the intensity versus theta plot, which is the XRD or the XRD of this structure. So we can calculate the structure factor using these various different peaks at various different position corresponding to the diffraction angle. So this tells about the structure of the structural density, electron density, and crystal system. So thanks.